Newton described gravity as just a force at a distance, okay? Action at a distance. But he was still mystified. How could it gap the vacuum of space? What's going on? How do we know each other? How do we know about what? Why do we know? Why? He knew his equations worked, so he went with it. But
that's some confidence.
It's still.
He's like, I know these are right. I can't prove it, but I am 100% sure.
I can't demonstrate it. What's going on in the mystery of the vacuum of space? But it's working. So
Exhibit A, trust me.
Trust me. So it's working. And Einstein said, gravity is not so much action at a distance. Gravity is a disturbance in the fabric of space and time. So disturbance is too violent. It is a shape of the fabric of space and time made by the existence of matter and energy wherever you might find it. Let's take a black hole, for example. A black hole is such a distortion of space and time that light cannot even escape. That's why we call it black. And you can't come out, it's a hole, black hole. Best named thing there ever was, ever. So if you're just somebody wandering by a black hole, you'll feel your trajectory altered by it. Newton would say that's action at a distance. Einstein would say that is the shape of curved space-time. And you're just following where space and time wants to bring you. It's like in NASCAR, are they actually turning left? No, because the track is banked. The bank turns them forth, turns the car.
I feel like the drivers would be very upset by this. Like, what are we training for?
Yeah, so their steering is primarily maneuvering in the traffic rather than making a left turn as they go around the track. So the track is shaping their path. In the same way, space and time will shape the path of anything moving, but light is the best tracer of this. What happens when two black holes collide? OMG. Black holes collide, they are already a disturbance in the space-time continuum. Now they come together, it is such a disturbance that they will create a ripple in the fabric of space and time, emanating at the speed of light. Is too violent. It is a shape of the fabric of space and time made by the existence of matter and energy wherever you might find it. Let's take a black hole, for example. A black hole is such a distortion of space and time that light cannot even escape. That's why we call it black. And you can't come out, it's a hole, black hole. Best named thing there ever was, ever. So if you're just somebody wandering by a black hole, you'll feel your trajectory altered by it. Newton would say that's action at a distance. Einstein would say that is the shape of curved space-time. And you're just following where space and time wants to bring you. It's like in NASCAR, are they actually turning left? No, because the track is banked. The bank turns them forth. Turns the car.
I feel like the drivers would be very upset by this. Like, what are we training for?
Yeah, so their steering is primarily maneuvering in the traffic rather than making a left turn as they go around the track. So the track is shaping their path. In the same way, space and time will shape the path of anything moving, but light is the best tracer of this. What happens when two black holes collide? OMG. Black holes collide, they are already a disturbance in the space-time continuum. Now they come together, it is such a disturbance that they will create a ripple in the fabric of space and time, emanating at the speed of light. So, many people don't know that Einstein wrote down the first equations that enabled the laser to be invented later on. This is crumbs on his plate.
Right.
Okay? When you're that brilliant, crumbs do great things because you're focusing on the main events, like the theory of relativity and other things.
The back page of his notebook just said tunnel laser.
So Einstein invents a new theory of the universe, the general theory of relativity, that predicts the existence of gravitational waves Shortly after that, he writes down the equation that permits the invention of the laser. Decades later, people invent the laser. Decades after that, they use the laser to measure and discover the existence of gravitational waves.
And entertain cats.
Yes. Einstein's a badass.
100%.
People getting Nobel Prizes off of crumbs that fell off his plate. All right. How about tides? Tides slosh back and forth. Love it. Well, we commonly associate tides with the moon.
Sure.
So the moon tides have nothing to do with the sun. So if you have a tidal thing that drifts with it and generates energy, it's also renewable because you're always going to have tides, but it's not traceable to the sun. However, 1/3 of the tides you measure comes from the sun.
How's it doing that?
Well, the full name is lunisolar tides. Loony moon, solar sun, lunisolar tides. The tides we all experience are lunisolar tides. And the moon is like 2/3 of it, and the sun is 1/3 at all times. At all times. If you're using tides, some of that is the sun. Most of it is the moon. And so there you have it. That's the difference from all of this. But if you pull fossils out of the ground, you're not renewing that. And when you run out of fossils, you're done. Oh, by the way, there's thermonuclear fusion. We haven't harnessed it yet. We know how to create it. They're called bombs. But when you harness it,
that's a lot of energy.
It's a lot of energy. You can create a power plant, and that's fusing hydrogen together to make helium. The sun does that every day. So we just be mimicking the sun on Earth. It's the nuclear fission that has dirty byproducts. And that's what the original atom bombs were made of, fission bombs. But nuclear fusion, that's the holy grail. But I saw a bumper sticker once that said no nukes. So it was a very green, sort of progressive, left-leaning bumper sticker, no nukes. But the O in the no was a sun.
Which is the ultimate nuclear weapon.
The ultimate nuclear furnace is the sun. Okay, if you had no nukes, you wouldn't be here. All right, well, you know what they mean, of course. They don't want, like, nuclear energy. They want solar energy, but solar energy is nuclear. I think at the time I saw this bumper sticker, it was still in the Cold War. So maybe they were talking about the nuclear arsenals, for sure. But the fact that they had a sun there, it still tells me that they were thinking of generating power.
Sure.
Yeah, use solar power rather than nuclear power. But one other quick source of energy, because the big problem with solar energy is how do you store it? If you want to use it at night, how do you use solar energy at night? You can't. Okay, tides still move in and out at night. That works. Hydroelectric, you can use that at night. That all still works. But how do you use solar panels? So there's talk now of using solar panels to lift heavy weights up a hillside, to turn photons into potential energy that then becomes kinetic later. So that's your storage battery becomes solar power lifting all these weights up into the air. So it's a successful way to store the solar energy that you had earlier, and then you could draw from it at any time of day or night.
That's amazing.
It's very clever. Yeah.
There's a lot of balls at the top of hills and like, don't touch them. This is
we
powering the whole city.
Yeah. So anyhow, there you have it. It's called the Big Rip. And I'm terrified. I'm terrified by this because I finally grew accustomed to the stretching of space and time, whatever even that means, right? Now you're going to tell me it's stretching and it's going to rip? Oh my gosh. So
do we know where it's going to rip? Are we near the rip site? Do we need to move a little bit?
Put some pre-stitches in it to keep it going?
Yeah.
No, it would rip at its very core. All places within the fabric would just disassemble. Rip and fabric go together as two words. But before we use the word rip and the fabric, we spoke of space as a rubber sheet that stretches. And maybe it can stretch forever. Like, we don't know. We just don't know. So now the specifics of the question was what?
It just said, what is it?
What is the fabric? All we can say is space behaves as though it is a stretchy substance. Pick any word you want to give it.
Right.
Maybe we should have called it the lycra of the universe.
Sure.
Or the
neoprene.
The neoprene. Right. I don't know. Call it anything, but we try to find an analogy that can make it more understandable. to you, to anyone, to ourselves. So fabric of the universe seems to fit the bill very well, right on up to the rip.
Right.
So that's why. And
that's when everything in the universe disassembles, including us.
Oh, you're made of things in the universe. So yeah.
I was trying to be optimistic.
Yeah, all the electrons, protons, and neutrons, they're not all going to break apart, but you'll be intact. Okay,
Yeah, exactly.
That'll be.
Do I feel it?
Yeah, I'm terrified by it. It is. If it happens at all, it'll happen in 22 billion years.
Oh, so we're okay. We're okay.
No, I got it on my calendar. So fabric is metaphor, but it's a very apt metaphor for what the universe is, because the universe can curve. It can curve back on itself. It can stretch. If you're not happy with fabric, come up with another term, but I think we're good.
That's pretty good.
All right.
All right. This question comes from Geezer Windbag. Greetings, Dr. Tyson. I'm curious why we say the universe exploded in the Big Bang. It seems to me more likely that the singularity expanded and fragmented, and the universe we see is still all within the singularity. An observer outside the original singularity would still see a singularity, though from our perspective, the universe is incredibly huge. Thoughts?
Okay. So a couple of things. If he doesn't like the word explosion, I'm okay with that, because the singularity that birthed the universe was the rapid stretch.
I was just wondering why black holes can't just be dark matter. There seems to be a lot of them. They are massive and seem to have more gravity. Most importantly, we can't see them.
Let's list the dark matter candidates. Would there be dark clouds? Could there be vagabond planets that are not illuminated by a host star that got ejected into the galaxy? Could it be black holes? It turns out the physics of the early universe limits how much ordinary matter there can be. Black holes count as ordinary matter because you make them from ordinary matter. It limits it. There's a delicate set of knobs that we're turning in the early universe to understand what the universe was and what it became.
Alan Rayer, he wrote, "Hello, everyone." Waving emoji, cowboy emoji. It's Alan from Lithuania. A lot of cowboys there. Always wondered about gravitational waves. Please explain how and what did they actually detect in 2015?
Oh, very nice. Yeah, so that's the first detection of gravitational waves was then.
Nice.
Interestingly, it was the near centennial. I think the prediction came out in 1916, but basically the centennial of Einstein's prediction that such a thing even exists. So it took a century to verify that what he predicted was correct. So just to put that in context, I have a book on my shelf that describes the new space-time that opens up after you fall into a black hole. Time changes for you, it ticks more slowly relative to everybody outside the black hole. So as you fall in, you will see the entire future history of the universe unfold before your very eyes, and a new space-time continuum open up.
That sounds awesome.
A whole
Minus the being ripped apart.
Minus the being ripped apart part. Yeah. So if the black hole's big enough, the tidal forces won't rip you apart. You can survive the fall.
Oh, that's cool.
Yeah.